We're going to be doing this question, which is finding the maximum length of a valid subsequence 2, right? So essentially you're given an array of numbers, and you need to find a subsequence such that this rule is being met. So what does this rule mean? It means that, like, for every consecutive element, every consecutive pair of elements, if you add them up and then you divide them by k, the remainder for the whole subsequence will be equal. So what does this mean, right? So let's look at example 2. I think it's a better example. K is 3, right? So in this example, the answer is 1 4 1 4. Let's see why that's the case, right? So if you have 1 and 4 here, you know that 1 plus 4 equals to 5, and 5 mod 4, 5 mod 3, because 3 is k, is going to be 2, right? And then you go on to the next one, which is going to be 4 and 1. 4 plus 1 is equal to 5, 5 mod 3 equals to 2. And the last one is going to be 1 plus 4 is 5, 5 mod 3 is going to be equal to 2. You can do the same for this as well, because 1 plus 2 mod 2 is going to be 1, 2 plus 3 mod 2 is going to be 1. Of course, all of them are odd sums, right? 1 plus 2 is odd, 2 plus 3 is odd, 3 plus 4 is odd, and 4 plus 5 is odd. So, if you look at the constraints of the problem, we can kind of see an approach to solve it. You notice that the length of the numbers is less than 1000, right? 10 to the power of 3. So this suggests that we can likely do a n square kind of operation, and this will not hit a time limit exceeded issue. So considering that, we can do dynamic programming, and if you have solved other problems similar which involve longest common subsequence or longest increasing subsequence, LIS, which is a common Leetcode problem, you will know that this is kind of similar, because you're trying to identify a subsequence within this array, which meets this criteria. And so if we see that kind of problem, and if we see the constraints are around 1000 in terms of length, we can likely use DP and the LIS pattern to solve this, right? Another reason why we can do this is because a subsequence means that, let's say given an array, a subsequence is something that you can take elements out, but the order of the remaining elements is not going to change. And so that's how you get a subsequence. So once you know that, right, you know that you can likely do a iteration, 2 for loops. Let's say if you're an element here, and then you can go through every element before it and see whether what's the longest valid subsequence up to this point, right? And the interesting thing about this question is the addition of the k being the remainder being variable, because the constraint is that all the remainders should be the same, right? Like the 0 at first element sum mod k, the remainder is the same as 1 plus 2 and rolling indices. So once you know that, we can likely use 2-dimensional DP. In the normal LIS problem, we have 1D DP, right? The DP is one singular array, and then we essentially we just need identify the longest subsequence up till index I. But in this problem, you need to take note of this other thing, which is the remainder. And one way we can do that is simply just by having a 2D DP array, right? So in this case, DP array is going to contain 2 dimensions. One dimension is going to be for the index, another dimension is going to be for the remainder, right? So I will explain why I set it to be 1 as I go through this loop, right? So I create this array, and then in LIS fashion, I iterate through each index in the nums, and then the second loop within it is going to be limited to all the elements that were before it. So if index is 2, I'm going to cover index 0 and index 1, right? And what I do is I have 2 indices now, right? I and x. I is a later index and x is an earlier index. I identify what the remainder is, right? So how do I do that? This is the criteria of the question, right? So I do nums I, which is nums of the later index, and nums x, which is of the earlier index, and mod k, right? This is going to be the remainder. And one thing to note is that since our DP is two-dimensional and keeps track of index and remainder, we can do the LIS operation of incrementing the length of the longest sequence based on the remainder. So what I mean by this is that like the longest increasing subsequence, the longest valid subsequence at index I and the remainder REM is going to be the longest increasing subsequence at um, at 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 index X, which is the index before, and the same remainder. Cause you want the remainder to be the same with every pair in the valid subsequence, which is why we do this step, right? After do this step, yeah, essentially, so this is like a candidate for the longest valid subsequence, right? Because it is the longest valid subsequence at index I at remainder REM, right? So what we do is we just do a max operation to compare between the the global result we want to return and the longest valid subsequence at index I and index rem, which is why we do in this step in line 10 here, and then you return the result, right? And the result is going to be the longest valid subsequence, right? For any remainder at the last index. At the end of the day, I mean at any index pretty much. So yeah, so that's how you solve this question, and yeah, hope you've enjoyed the problem. And yeah, it's a pretty interesting problem, and as you can see, it is pretty efficient time wise. Yeah, thanks for watching.